most important statistical tool as well as the mathematical tool to test the hypothesis whether the exact idea from the data set is true or not. So let's begin that the data is categorized into two categories. The first one is 11:15 is already done. I thought. Wait. Hello everyone. In today's session, I'm going to teach the chi-square test, which is one of the most important statistical tool where a researcher tests the hypothesis whether the exact idea has been fit to show some meaningful evidence or not. So let's begin the data. Data are classified into two categories. The first one is qualitative data and the second one is quantitative data. So when it comes to the qualitative data, chi-square test will come under the qualitative data where the nominal and the ordinal variables are measured. When it comes to the quantitative data, the other you can see the tests like t test, z test, f test are mainly based on the quantitative data or where the variables like ratio, you can see the variables are included under quantitative, which refer to such tests that are t test, f test and z test. So let's begin the classification of the chi-square test or chi-square test. The most or main difference between the chi-square test and the other hypothesis test like t-test is the nature of the data. For a chi-square distribution, the data are mainly are frequencies rather than the numerical scope, which are mainly classified into the exact class interval or the continuous data, or that's mainly have a difference between the major test, that is the chi square test and the t test, or you can see the f test, z test, min whitening test, where the class intervals with their respective frequencies are measured. But in chi square test, the data are mainly measured in frequencies. Like for example, we talk about the discrete data, we talk about the other categories of the variables which are also considered in chi-square test. Like we can talk about the for example, we can talk about the association between the knowledge and the demographic variables. We can also to find out the relationship between the age and the awareness level. We can also test the association or the relationship between the, you can see, the perception level and the, you can see the other demographic variables like occupations to you can say student age, etc. So let's begin with the definition. The chi-square test is a statistical procedure to determine the exact difference between the observed and expected data. Now the question arises, what is the difference between the observed and expected data? Observed data is an individual data. We can see the individual series where the exact values of a particular data set has been given in the particular you can see scenario or in a particular question. But when we talk about the expected data, a mathematical formula will be used to calculate the frequencies from the observed data. I repeat once again, expected data are basically, or you can say, is mainly defined as a mathematical formula which will be calculated from the observed data. And such test will be used to determine or to estimate whether have any two variables any correlation or not, or whether any two or more variables, you can say a categorical variables in our data set or not. It also helps to find out whether any difference between the two variables is actually related to each other, or actually are associated with them or not. And that stands for chi-square test. So when a particular researcher are willing to test or to find out a difference between the two variables, or to associate between two variables, or to find out the relationship between one or two or more variables, then a particular researcher will apply the chi-square test. Let's talk about that on what basis such test will apply. Chi-square test is mainly used to test the significance of the patterns in qualitative data. For example, the patterns of changes, we can say, in awareness level, in knowledge level, in perception level, you can say in the experience level, where the qualitative such variables are mainly are qualitative in nature, then the chi-square testing or will be applied. Statistic. Basically, statistic is mainly based on count. It's mainly based on the frequencies where it fall in any category or each category. When we talk about under chi-square test, the test statistics measures the agreement between the observed and the expected frequency. In other words, it also shows that what would be the exact difference between the actual count. In other words, we call the observed frequency and the expected count or expected frequency by assuming the null hypothesis. What is null hypothesis? Null hypothesis stands that there is no significant difference between two or more variables, or in other words, there is no relationship between or no significant association between one or two variables, and that's called the null hypothesis. So under chi-square test, the null hypothesis will be applied, and after that, we using the mathematical formula to test whether any relation or association between the variables or not. And on that basis, our fit of the data, the researcher will apply this test. So this is a mathematical formula which is called the chi-square in a Greek letter, or in other words, we call the chi-square, that is x square, is equal to summation. O stands for observed frequency, or you can see the observed individual with the given phenotype. That means the frequencies in respective of the one variable. E stands for expected frequencies, or in other words, we can see the expected individual with a given phenotype. And when we subtract to these frequencies and make it the square of that exact value of the difference between the observed and expected frequency and divide or by expected frequency, that value is called the chi-square calculated value. That's the exact formula of the chi-square, which is equal to sigma O minus E whole square by E. E stands for expected frequency and O stands for observed frequency. So when you add all of the difference between the observed and expected frequency and square one by one and just divide by the expected frequency, you will get the calculated chi-square value after using this mathematical formula. Let's talk about the fundamentals of hypothesis testing. So before any researcher will apply this test, it is very important to understand the two main types of hypothesis which will used in testing the exact declarative statement. So basically, what is hypothesis testing? It is a one of the techniques for interpreting or drawing the conclusions about the population based on the sample collected by the researcher. It also determines that which sample data will best support mutually exclusive population claim. So whatever the population claim, which type of data set will be best support our conclusions, our interpretations, or our analysis, and that's called the hypothesis testing. It classified into two categories, that is null hypothesis and alternate hypothesis. What is null hypothesis? It totally stands that there is no, means no, significant difference between the two variables, or no significant association or no significant relationship between two variables. Hence, the exact declarative statement will be rejected. So, for example, if we say there is no relationship or no association or no difference between the age and education, it means it is called the null hypothesis. So let's talk about the second category, that is alternate hypothesis. If I say there is a difference between the age and gender, it stands alternate hypothesis. The alternate hypothesis logically, or you can say in other words, opposite to null hypothesis. The mainly whatever the researcher prepare a declarative statement or an assumption based on the exact research that stands. So whatever the researcher decide any declarative statement, it means that it is a significant relationship between two variables. H1 is a symbol of alternate hypothesis, and H0 is a symbol of null hypothesis. Types of chi-square test. There are two main types of chi-square test, which is called independence and the goodness of fit. What is independence? Independence, it is one of the inferior statistical tests which mainly examine whether the two set of variables are related to each other or not, or are likely to be related with each other or not. This test is mainly applied when any nominal, or you can say any ordinal variables are measured or and it also considered as a non-parametric test. So any variable which are measured at the nominal or at the ordinal category, such particular measurements are called non-parametric test. So when we talk about the goodness of fit, which is another type of the chi-square test, in statistical hypothesis testing, such category is mainly determine whether a variable is likely to come from a given distribution or not, whether a particular a set of values, or we can say a particular set of data, a particular set of values or a data set is actually a good enough to fit for our idea or not, or in other words, we can say whether it is also a representing a exact or correct sample for the entire population or not, and that's called the goodness of it, and whether the exact values of our data are actually fit for our idea or not, and that's called the goodness of fit, which is the second type of the chi-square test. Let's talk about the steps of chi-square hypothesis testing or chi-square hypothesis testing. So first one is data, which is measured on counts like frequencies or any proportion. Second is you have a researcher has to assume that is a random sample selected from a population. There are two hypotheses, and any of the hypotheses a researcher can count on. That is null hypothesis and alternate. So if we talk about null, no relation or no difference, no association. If we talk about the alternate hypothesis, is any significant difference, yes, or significant relationship or any significant association between one or two variables. So when a researcher apply the chi-square test, the hypothesis statements is compulsory to make. Let's talk about the one of the major concept, that is the level of significance and the degree of freedom. Degree of freedom, a symbol is DF in small letters. The level of significance, that means the degree of freedom, is that level of significance which is one of the measurement of the statistical significance. Such a particular tool is mainly defined whether the null hypothesis which is assumed by the researcher is to be accepted or rejected. So it is one of the you can say a tool which always defines whether the particular hypothesis, null hypothesis which is being assumed, is accepted or not. And if it's something define such statement, that's called the degree of freedom. It is also using the degree of freedom, that is DF. It is also expected to identify if the result is statistically significant for the null hypothesis or not, or whether the null hypothesis to be false or rejected. So these are the rules of calculating the degree of freedom or using the mathematical formula. So when we talk about the DF first application, it means the first category of the data where uncount of data or the values of the data will be indicated. Then the degree of freedom will be calculated as like, that is k minus 1. K is a number of groups. It would be the multiple groups, it would be the 1,000 groups, it would be the 100 groups as well. So how to calculate the DF is, if it is 100 groups, the 100 minus 1. It means 99. If there is set of values has been given 50, so then the K is 50. So in the second category and third category, when we talk about the second and third category, we always talk about the contingency data, or you can say the contingency tables, where the rows and columns will be given. So as accordingly, the degree of freedom will be calculated based on the formula given on the screen. That is the column minus 1 into row minus 1. So it depends how many columns has been given in the particular scenario, and no matter that how many rows has been given in the particular scenario. So when you subtract minus 1 and just multiply to each other, you will easily calculate the degree of freedom in case of contingency section or in case of contingency table. So for example, if the degree of freedom, that is DF, is 1, the tabulated chi-square value. What is tabulated chi-square value? We talk about the table value. We talk about the chi-square distribution statistical table. So let's have a look how the tabulated chi-square values will be looked like. Just have a look here. This is called the tabulated oblique critical chi-square value. It is one of the chi-square distribution table which you can anywhere, or you can see a statistical table book. And when we see if the DF, that is degree of freedom, is 1 and the significance level is 0.05, then the value is 3.841. So let's come forward to the previous or the earlier slide over here. Degree of freedom, if the DF is 1, the automatically the table value under the chi-square distribution is 3.841 always. And when such degree of freedom will be drawn on the graph, it on the one sided, it always be positive. So when we talk about the degree of freedom and when we talk about any of the values comes under the, based on the degree of freedom, all the values will be positive. No value will be negative under the chi square tabulated, or you can table, you can say. The next concept is level of significance. What is level of significance? Level of significance is a measurement of the statistical significance, that whether the null hypothesis is actually accepted or not, whether such null hypothesis shows any significant difference or association or relationship or not. Basically, such particular tool will be used to test the null hypothesis, then whether it will be accepted or rejected. Whether null hypothesis, whether the particular researcher, the statement that is being made under null hypothesis, which stated null hypothesis is actually false or true or rejected. And that's called the level of significance under chi-square distribution test, or under the chi-square test. The level of significance would be the 0.01 or 0.05. And these level of based on these level of significance, the null hypothesis will be tested by the researcher. So this is all about the level of significance, which is one of the measurement of the statistical significance. So these are the 4 rules of the level of significance to find out and to judge about the null hypothesis, whether it could be or likely to be accepted or not. So if the P stands for level of significance. P is a symbol of a level of significance. So if the P is greater than the point 1, then it means there is no assumption to be made by the researcher for a null hypothesis. No assumption will be made whatever the null hypothesis has been stated by the researcher. If the P is greater than the 0.05 and if the P is less than the 0.1, that means there may be a chances to assume whatever the researcher has made the null hypothesis statements. When we go to third rule, if P is greater than the 0.01 and the P is less than 0.05, what is 0.01 and 0. These are called the level of significance where a particular null hypothesis or alternated hypothesis will be measured. So if the P is greater than 0.01 and the P is less than 0.05, then there must be a strong assumption about the null hypothesis. So before making the research, before making any declarative statement, researcher has a strong assumption, a strong valid assumption statement has to be given to prove and statistically, and that is the main of significant, that is the main level of significance to be used, that is 0.01 and 0.05. These are the 2 level of significance where the exact null hypothesis or where the status of the null hypothesis will be calculated or estimated. If the P value is less than the 0.01, that means there is a strong assumption is to be made about the null hypothesis by the researcher, and it always been indicated in the results as well. We can see the calculated results using the following data set by the researcher. So these are the four categories. These are the four basically rules of the level of significance. If the P is more than or less than, there would be no assumption. There would be a low assumption. There would be a very strong assumption. There would be a strong assumption about the null hypothesis. And accordingly, the researcher will prove statistically using the calculation, using the mathematical formulas, tabulations, tabulated values, or you can say the table values that the chi-square will be considered. These are the rules of the chi-square test. The first one is statistical decision, and then accordingly we conclude the statement. That is called the null hypothesis statement. If the calculated chi-square value, there is a formula which has been shown in the earlier slides. The formula, if a researcher use that formula and whatever the value comes, that calls the calculated chi-square value. If the calculated chi-square value is less than the tabulated chi-square value. What is tabulated chi-square value? The value which is being estimated or which is being based on the chi-square table. So that's called the tabulated chi-square value. So the first rule is if the calculated chi-square value is less than the tabulated chi-square value, it means the null hypothesis will be accepted. It means the null hypothesis may be true. And that is the first rule, that how to conclude your hypothesis statements. So the first rule says if the calculated chi-square value is less than the tabulated chi-square value, then the null hypothesis will be accepted. It means whatever the researcher has made the statement, it may be true. And in that case, it will be, and such particular rule will be applied, and if the level of significance will be 0.05, or in other words 5%. If second rule says, what is the second rule of the chi-square test? If the calculated value is more than the tabulated chi-square value, it means the null hypothesis will be rejected. It automatically, if the null hypothesis will be rejected, that means the alternate hypothesis will be accepted. In other words, there is a relationship between two variables, there is a association between two variables, or there will be a difference between the one or two variables, and that's called the second rule, where, and it can be verified if the calculated chi-square value is more than the tabulated, means table chi-square value. If the calculated chi-square value is less than the tabulated chi-square value, that means the null hypothesis will be accepted. And when the null hypothesis will be accepted, what does it mean? It means there is no significant difference, there is no significant association, there is no significant relationship between one or two variables. So these are the rules of the chi-square or chi-square test, which will be applied once the researcher will calculate the chi-square or chi-square value or tabulated value. And accordingly, the researcher will apply the rule and conclude the hypothesis statement. That's called result. So this is the second category or second application, that is contingency table. Contingency tables are classified into row and column. So this is the format of the contingency table. So the first category of classification and the second category of the classification has been given the values, the counts It called them observed counts because whatever the values given in the question are the observed count. What are the expected count or expected frequency? It will be calculated using the following formula from the observed frequency. So that is the, and whatever the values A, B, C, D is the observed frequencies. What is the total over here in the column to row total and the column total? When we talk about the row total, that is A plus B, C plus D, and the you can see the column total, that is A plus C and B plus D. So whatever the observed frequencies has been given in the table, that values to be added together, and accordingly we calculate the total of row and column. So what is in over here? It means whatever the total of row and column must be equal. That's called, the N stands for grand total. So if the row total is 50 and the column total is 50, total is 100. That means the N should be 100. If the overall, the total of columns and the total of rows, you can see if different, that means there should be a calculate problem, there should be a calculation problem. So you need to verify using the own calculations by doing own or using the calculator. A simple calculator will be used to calculate the values of the table and the values of the exact questions. So let's take an example over here. A total of 1500 workers on two operators, let's say A and B, were classified as deaf and non-deaf according to the following table. So what is the question? Is there any association between the deafness and the type of operator? And what is zero point zero 0.05? It is a level of significance, alpha. We denote the word level of significance, that is alpha, at 0.05. So 0.05 is a level of significance. Degree of freedom you need to calculate based on the question, right? So this is the exact question. 1500 workers, it's already given total 1500 on two operators, and the data is given below. This is the data has been given to you. Operator, there is A and B. There are two categories divided, deaf and non-deaf. So these are the values: 100, 960 under deaf and 900 and 440 under not deaf or non-deafness. And this is the total. Total has been given to you, that is 900 plus 100, 1000, 440 plus 60, it becomes 500. So when this is a total of this is a row total. So when we talk about the column total, that is 100 plus 60 is 160, and 900 plus 440 is 1340. And when we talk about the overall total of the row and column should be equal, that is 1500. So when you add the row total and when you add overall, add the column total should be matched, and that's it, that is 1500. So all the information has been given. This is a question. This is a table given in the question, and accordingly you have to calculate and apply the chi-square test. So now the question is being asked: is there any association between deafness and type of operator? Either you can make null hypothesis, either you can make alternate hypothesis. So if you want to make null hypothesis, simply say there is no association between deafness and type of operator. So you can make into a null hypothesis. If you want to make an alternate hypothesis, you can easily say, you can easily make the statement there is an association between the deafness and the type of operator. So you can either make an alternate hypothesis. So it's your choice. Either you make null hypothesis, either you make alternate hypothesis. Both will be verified using the statistical calculations. So this is a question given to you, the table in under row and columns, and accordingly the total has been given. So this is the exact, you can say the simplification about the total number of items is 1500 and the total number of defective items is 160, right? So this information or simplification is being given on is taken or considered from the table itself. So now E stands for, as I already told earlier, that the expected frequency will be calculated from the observed frequencies. So if you look at the table, observed frequencies has already been given 100, 960, 440. These four values are the observed count or frequencies. But and how to calculate the expected frequency? This is the formula given to you on the screen. TR, what is TR? Is the total of row. What is TC? Is the total of column. By GT is a grand total. So let's talk about grand total. Grand total is 1500. Whatever, when it comes to the grand total is a total of row plus total of column. So when you add together, it becomes grand total. So when we talk about the total of row and total of column, so you can see total of row. If we talk about the total of row A, 1000, if the total of row B, 500. If the total of column, if the total of column of div is 160 and the total of column of non-div, that is deafness or defective, that is 1340. So these are the total of row and total of column and by grand total. So this is a formula of expected frequency. So before to come into the result, you need to calculate. So once you have a question, once you get to know about the observed frequency from the table, your next step is to calculate the expected frequency using the following formula. So this is the formula that how to calculate the expected frequency. So let's begin from it. You need to calculate the expected frequency of div 100 of operator A, operator B, and again the expected frequency of operator A under non-deafness and B under non-deafness. So we have calculated the expected deafness of from operator A, that is you can see 100. We have to calculate the expected frequency of observed frequency 100, right? From operator A. So let's begin the formula over here. Total of row. So when we talk about the operator A of total, that is of row total, that is 1000 into total of column. What is the total of column of deafness? That is 160. So once you multiply 1000 into 160, divide by grand total, that is 1500. If you see the 1500, that is grand total. So you need to calculate the expected frequency of 100. So what is the formula of expected frequency of 100? That is the row total into column total by grand total, that is 1500. So 1000 into 160 by grand total, that is 1500. So you will get the expected frequency of operator A under deafness, that is the 100. That expected frequency under observed frequency, that is 100, is 106.7. Let's talk about the expected frequency of operator B and under deafness, that is 60. So what is the total of row of B operator is 500. What is the total of column of D, that is 160, divide by 1500. That means 500 into 160 divide by 1500, you will get the expected frequency from operator B under deafness category. So this is the expected frequency of operator B under deafness category. Now we have to calculate the expected frequency of non-deafness, that is 900 and 440. We need to calculate the expected frequency of 900 from operator A and the 440 from operator B. So how to calculate this? It's very easy. Use the formula of expected frequency. Total, let's talk, we have to calculate the non-deafness, that is 900. So the total of row 1000 and the total of non-deepness, that is column, that is 1340, divide by grand total. That means from to expected frequency, that means expected of non-deafness from operator A. What would be the expected frequency? 1000 into 1340 divided by grand total. Now the second is 440. 500 into 1340, that means row total into column total by grand total, that is 1500. So 500 into 1340 by 1500, you will get the expected frequency of not deafness under B operator. So this is the formula. This is the main formula of calculating the expected frequency. So in each row and each column, you need to calculate the expected frequency of all four observed frequencies. So this is the table has been given to you, the result, this is the exact result given to you, and now you have to show the table of expected frequency. As I told, these two figures is already being calculated in the earlier slide. Expected frequency, expected D of operator A, expected D from operator B. So T2 values already been calculated, 106.7, 53.3 is already shown on the screen. When we talk about the non-deepness, these are the values has been calculated. How the expected frequency of non-deepness has been calculated, that is 900 row total into column total by 1500, 450 row total into column total by 1500. So once you do the calculation, the exact value has been written on the screen, that is 893.3446.7. So these are the expected frequencies has been calculated. Now, once you know the observed frequencies has been given in the question, after calculated the expected frequency, a particular values has been estimated. Now, now the time comes to apply the chi-square formula, which is a mathematical formula. And what is the mathematical formula over here? This is a mathematical formula, that is chi-square sigma O minus E whole square by E. So this is a mathematical formula which will be used in this particular question. Now, once you calculated the expected formula, you must aware what would be your hypothesis statement. So this is the hypothesis statement which I already told in the beginning of this question. That is null hypothesis. There is no significant association between type of operator and deepness, and alternate, that is HA. There is significant association between the type of operator and deepness. So any of the hypothesis statement a researcher can make based on such question. So level of significance is already being given in the question 0.05. It could be 0.01 or it could be 0.05. Mostly and accurately per level of significance will be used. That is 0.05 or 0.04. Anyone could be used. But in the question, it is mentioned 0.05, the level of significance, that is the alpha level in other words. So that is the level of significance has been indicated, that is 0.05. DF is a degree of freedom. Now, in this particular question, row and columns has been given. So accordingly, we have to use the formula of degree of freedom. R minus 1 into C column minus 1. C stands for column. So row is 2. If you check out the exact table, so row it's 2, column is 2. So same here, the R is 2, that is row, column is 2. So once you subtract and multiply the values, you will get the degree of freedom is 1. So now degree of freedom is 1 and the level of significance is 0.05. So now we have to calculate, we have to check out the tabulated chi-square value from the table. So let's begin. Degree of freedom is 1 and the level of significance is 0.05. So this is the table given to you. So degree of freedom, if you check out the degree of freedoms will be given in the columns, that is 1 to 1000, and the significance level, which is called the alpha level, which is given in the row, that is 0.99, 0.95, 0.9. It is these significance level values will be mentioned in the question. But in my question, the level of significance is 0.05 and degree of freedom is 1. So what is the tabulated chi-square value from the table? That is 3.841. So this is the tabulated chi-square value. Why we are calculating the tabulated chi-square value? Because we have to test the null hypothesis, and to test the null hypothesis, it is compulsory, it is mandatory to calculate the tabulated chi-square value, and based on such value the researcher will get to know whether the null hypothesis is accepted or rejected. So this is the degree of freedom 1 for 0.05, which is already seen in the table, that is 3.841. So just have a look on the screen, that is degree of freedom 1 and the 0.05, that is 3.841. So this is a value has been estimated. It is called, in other words, that is tabulated chi-square value, or in other words, we can also say critical chi-square value. This is a formula O minus E whole square by E, that is sigma. So one by one of the observed frequencies and expected frequencies will be calculated, and accordingly we use the formula. So we have just elaborated the formula because there are 4 observed frequency. That means the 4 values, the 4 subtractions will be used. That is like this. So in the formula, so this is the question. Now what is the formula is O minus E. O is 100, E is 106.5. So let's begin. Use the formula. Sigma O minus E whole square by by E, that is expected frequency. 100 minus 106.7 by 106.7. 60 minus 53.3 by 53.3. 900 minus 893.53 by 893.3. 440. What is O here? 440. What is E here? 446.7. Whole square by expected frequency, that is 446.7. So you have to subtract from observe O minus E, square it and divide the expected frequency and just add it together, and that's called the chi-square value, which has been shown in this formula. So there are four observed frequency, the four values to be calculated of chi-square. O1 minus E1, that means O1 minus E1. What is O1 minus 100 minus 106? 60 minus 53. That is O2 E2. And again 900 minus 990, 893.3. That means O3 E3. O4 E4. That is the coding has been given for the convenience to estimate the values. So you can use any of the coding by your own. Just use the formula. That is O minus E. O minus E. O minus E, that again non-devious O minus E. O minus E. Once you subtract all the values, square it, divide by the all one by one the expected frequency, add it. You will get the calculated chi-square value. So once you have used this formula in every question of related to row and column, so this is the values has been calculated. 100 minus 106. If you see on the table in the earlier table, if you see on the earlier table, this is 100 minus this minus 60 minus 53.3, which is being calculations also being given. 100 minus 106.7 whole square by expected frequency. Then we talk about the second observed, 900 minus 893.3 whole square divided by expected frequency, and so on. You will get the calculated chi-square value, that is 1.41. If you see the calculated chi-square value and the tabulated, that is table value of chi-square, that is 3.841. So this is the statistical decision. The calculated 1.41 is a calculated chi-square value, and what is the tabulated chi-square value? That is 3.841. This is the tabulated chi-square value, and the calculated chi-square value is 1.41. So now we have to take up a statistical decision. And what is the two rules over here, which I already explained? I repeat the rules. If the calculated chi-square value is less than the tabulated chi-square value, then in that particular case, the null hypothesis is accepted. That means there is no difference, no correlation between one or two variables. So in this particular question, the calculated chi-square value is 1.41, and the tabulated, what is the tabulated value? This is the tabulated value, that is 3.841. So the first rule is that, what is the first rule? If the calculated value, chi-square value or chi-square value is 1.441, is less than the tabulated chi-square value, that is 3.841. What would be the result? There is no relationship. That means there is no association between the type of deepness and the type of operator. I repeat, there is no association between the number of deepness and the type of operator. So this is a result. You can see the statistical result, that is calculated chi-square value is less than the tabulated chi-square. This is a result because from the values we applied the rule over here. These are the two rules. Less calculated chi-square value is less than and calculated chi-square value is more than. So this is the result in front of you on the screen. We accept the null hypothesis. That means the null hypothesis may be true. The result of this question, there is no significant association between the type of operator and the deepness. So this is the result of the chi-square test. You have to remember the formula, use that formula, and use the you also keep to know the expected frequency, or how to calculate the expected frequency, and you should know the formula as well. So once you know these two formulas, once after that you can once you apply these formulas into the form or given a data set, you can easily conclude the hypothesis statement based on the or apply the chi-square or chi-square test. This is also the another numerical question which is given to you in the form of the frequencies. This is all given to you. That is, Nadeep is testing an audible die to see if it is unbased or not. The results are given below. Score is already given 8, 1 to 8, and frequencies 7, 10, 11, 9, 12, 10, 14, and 7. Test the hypothesis that the die is fair or not. You have to make the null hypothesis, alternate hypothesis. Just if you make a null hypothesis, there may there may not be a chances that the die is fair. Null alternate, there may be a chances that the die will be fair. This is the alternate hypothesis. Any hypothesis statement could be made based on the question only. So this is the calculation, this is the solution given to you in the overall solution. When we talk about that there is no row and column, there is always an individual values has been given to you, a frequency, individual frequencies based on the scores. So these are the frequencies given to you. Then how to calculate the expected frequency? Just to find out the average of the observed frequencies. So this is the formula has been given to you, that is mean. How to calculate the mean in case of individual series? If the frequencies have been given to you, add all the numbers, all the values, all the count, and just divide by the number of scores. Number of scores is 8, and the total of the frequency is already given to you, that is the 10. So the frequency of the result is 10. That's called the expected frequency. So if the 10 value has been given as expected frequency in this particular question, and if any of the question has been given like this, the expected frequency will remains the same in or under all the observed frequency. So let's begin. Observed frequency is already given 7, 10, 11, 9, 12, 10, 14, 7. Just write it down O, observed frequency. How to calculate the expected frequency? Add the observed frequency, divide by the number of items. 1, 2, 3, 4, 5, 6, 7, 8. 8 is a number of items, and just add all the observed frequency or individual frequency. Just add and divide by the number of items. You will get the exact the expected frequency, that is 10. So you will apply this expected frequency under in all the observed frequency 10, 10 each. So once you calculated the expected frequency, you need to find out the difference between the observed and expected frequency, that is O minus E. So one by one you need to subtract, that is 7 minus 10, 10 minus 10, 11 minus 10, and so on. So once you calculated O minus E, just square the difference between the observed and expected frequency, square it, just square of the difference between two basically frequencies, that is 3 square 9 0 1 1 2 4 then 16 then 9. So once you square the frequencies, just divide by expected frequency, that is O minus E is already been calculated. You have to divide from the expected frequency. 9 divided by 10, 0 by 10, 1 by 10, 1 by 10, 4 by 10, 0 by 10, 16 by 10, and 9 by 10. You will get the exact values of the division. So once you add, you will get the chi-square value, that is 4. So you will get the calculated chi-square value 4, and the table value which is already been calculated, that is critical value, is a table value of chi-square 14.07. Just apply the rule. What is the rule over here is a calculated value is again the less than the tabulated value. It means the null hypothesis is accepted. That means we can conclude that there is an Nadeep has already concluded that there is an evidence to support the hypothesis, that is dye is fair. That's all for today, and thank you so much for this session. Namaste to all.